Hello, in today's video we're going to cover t-tests and JASP. Inside of t-tests we're going to look at one sample test, a two sample test, and a paired sample test. Alright, and to do this we're going to look at our data set that we captured this at the beginning of the semester with the survey that we sent out to our peers. So here's our data set, and the first one we're going to look at is a one sample test. A one sample test basically means that you're going to compare a set of data to a known value. And so for this example, we're going to look at the question that asked, how many hours of sleep do you get a night? And we're going to test the hypothesis that people sleep an average of 7 hours per night. So we don't really care if they sleep more or less per se, but we want to know, do people sleep a significantly different number of hours on average than 7 hours? All right, so Q10, question 10, is our sleep question, and you can see here we have how many hours they sleep a night. And we're going to test to see if they sleep an average of 7 hours. To do that, we're going to go to t-test and then a one sample test. So again, we want to look at the variable question 10 underscore 1 clean. We'll throw that over into variables. And then we want to select the correct things down here. Students t-test is what we're going to look at. Later in the semester, we will learn a little bit about non-parametric tests. That's what Wilcoxon sign rank test is. And then what we want to do is test the value. So we want to test, is the average amount of sleep different than 7 hours? Notice that we have not equals to, so that means different. We could test, do they sleep greater than 7 hours or less than 7 hours? But for this example, we're just going to test, we're going to test the hypothesis that they sleep equal to 7 hours or different than that. The other thing that we want to make sure that we have is our descriptive statistics over here. This will allow us to fill out all the information that we need when we report our statistic. All right, so there's our choices, and then over here is our output. First off, we're going to go through what is our test statistic. Our t-test is -6.88. The degrees of freedom for our test is 512. And then lastly, our p-value is less than 0.001. Now, we also need to report our mean. The mean that we had was 6.61. And so we would say something to the effect of, in our sample, the number of hours that our sample slept was an average of 6.6. And this is significantly different than 7 hours. And so again, you would say, let's see, parenthesis t, and then a bracket, and our degrees of freedom 512, close bracket, equals our test statistic 6.88, comma, and then p is less than 0.001. All right, I'm going to go ahead and close this out. Remove. Yes. The next thing we want to look at is a two sample test. And so with the two sample test, we're going to look at our stress variable, and we're going to test whether or not the amount of stress on average for males is equal to the amount of stress on average for females. Now, I will say this, this will give us a little bit more insight into this program. Right now, gender is question 9. So I'm going to scroll over to question 9. And inside here we have males and females, but we also had a third choice that was something like choose not to answer. And so if we want to test males versus females, what we're going to have to do is filter out that third choice. So filter out, I'm going to click on the question 9 variable title, and then it brings up this little option in here, and all I have to do is uncheck prefer not to say. And so you'll see that it changes to an X, which is then filtering out. And you see this little symbol on the variable here that says, hey, this variable is filtered. But now we have two options, male and female, or two categories. And so we're going to test if the stress is equal for males to the stress for females. So again, we're going to go to t-test, and this time we're going to choose independent samples t-test, because the stress for males is independent of the stress for females. All right, so what we have to do is select our grouping variable right here, and that's going to be our gender. So question 9, wherever that is, right there. and then the variable that we want to test. In this case, we want to test the amount of stress. Stress is at the bottom, so here's stress. So I'm going to move it over to variables. All right, now what do we need to check? This is an independent samples t-test is different in that we need to determine the test is different if the variance between the groups is the same or different. So we have to determine if the variance is the same or different. Now, how do we do that? That's with this equality of variances test down here. The equality of variances test, you always want to check this, is testing the hypothesis that the variance for males is equal to the variance of females. And notice that when I check this box, this additional assumptions check comes up, and it's the test of equality of variances. So if the variances are the same, we're going to use a student's t-test. If the variances are different, we're going to use what's called Welch's t-test. And so we have in here, again, I've selected Welch's and I've selected equality of variances. And basically, if this p-value is less than 0.05, that tells me that the variances are different. So then I would use Welch's. But in this case, the p-value is greater than 0.05. So that tells me that the variances for males is equal to, or it's not different than, the variances for females. So therefore, I can use the student's t-test. So because I'm using the student's t-test, that my test statistic is negative 3.7. We can round that 6 up to a 7. My degrees of freedom is 496, and my p-value is less than 0.001. I will say, the vast majority of time, the p-value doesn't, it has very small changes between the two tests, but sometimes it is different. So it is quite important to always test the variances. On independent samples t-tests, we first check the variances for the groups to see if they're the same or different, and then that informs us whether or not to use the student t-test or the Welch's t-test. Again, students is if they're the same, and Welch's is if they're different. The last thing I need to check in order to fill out all my information is the descriptive statistics, and again, this gives me the means for my two groups. So the stress on average for males is a score of 27.9, and the stress on average for females is a score of 30. And again, given our sample, given our data, the higher the average stress, the more stress the people are under. So this is saying, number one, that females on average have a stress score of a 30 compared to males who have a stress score of a 27.9, and that is significantly different. And so again, to do our APA format, we would do parentheses, T, and then brackets, and inside the brackets, we're going to give the degrees of freedom, 496, close bracket, equals our test statistic, which is negative 3.77, comma, and then our p-value. P is less than 0.001. All right. Now, I will say, if the p-value for the test of variances is significant, that tells us you're going to use Welch's, and therefore, if you were to use Welch's, then you would use the Welch's test statistic, the Welch's degrees of freedom, and the Welch's p-value. All right. All right. And then lastly, we're going to cover a paired samples test. All right. Now, I have to be sure that right now I have this filter on, so I'm going to remove the filter. All right. All right. And then I'm going to close that box too. So this time for a paired samples test, the paired samples test says that the variable is not independent of the other variable. The group is not independent of the other group. So in this case, we're going to test per person. Does a person read an equal amount of leisure? So how many hours in a day do you read is 10_2, and how many hours in a day do you have leisure time? And we're going to test the hypothesis that their reading time is equal to their leisure time. And this is a paired sample test. So we're testing this by individual. So we're going to take the average. What we're not going to do is independently take the average of all the reading time and then compare it to the average of all the leisure time. Instead, with a paired sample test, what this is going to do is it's going to do a pairwise test. So we're going to take per person the reading time and subtract off the leisure time. And then we're going to test to see if that is different than 0. So notice that 4 minus 2 means that this person reads 2 hours more than they have leisure time. But down here, This person has 3 hours of reading time and 3 hours of leisure time. So probably much of their reading time is their leisure time, possibly, but they have an equal. So their difference is going to be 0. So we're going to be averaging the differences. So this will be a 4 minus 2 or a 2, a 1 minus a 3 or a negative 2, all the way down, and then zeros and whatnot. So that's what the average is going to be. It's going to be the average difference because this is a paired samples test. So how do we do that? Again, we go into a t-test, and then now we're going to select a paired samples t-test. And again, we want those two variables, reading and leisure. So reading is 10_2, and then leisure is 10_4. And so here's my pairs, okay? And then again, right now we're doing a student's t-test. However, later in the semester, we will learn about non-parametric tests, and that would be the Wilcoxon sign rank test. Again, the hypothesis we're testing is that they are equal, so we're going to choose this alternative hypothesis. Measure 1 is equal to measure 2. If we wanted to check our normality in our groups, we can do that, and that would inform us whether or not to use the non-parametrics. And then in this case, I also need to get my descriptive statistics. And my descriptive statistics is going to give us the mean that we're also going to report. All right, so here's our output now. And notice that it says question 2 minus question 4. So the minus sign tells us kind of the direction. It's important to know which one is being subtracted from which so that you can understand the differences. But again, on average in our group, their leisure time was a 2.9 hours, where their reading time was a 2 hours. And so that's where we get this difference of, reading minus leisure. So our test statistic is 6.94. Our degrees of freedom is 402, and our p-value again is less than 0.001. All right, so to report this, again, you can use your notes, but we're going to use APA format. So I would say something, I could write a sentence and I could say the average reading time, and then I'll put in parentheses their mean of 2.02, is significantly different than the average leisure time, which is a mean of 2.92. And then I would do my APA format. So I would do parentheses, T bracket, and then inside the bracket, I would put the degrees of freedom, 402, close bracket, equals the test statistic, negative 6.94, comma, and then my p-value, p is less than 0.001. That concludes our video. Have a great day.